What I want to cover in these slides is basically the fundamentals of academic research. So this whole series is going to cover research methods from literature reviews, introductions, how to write a journal paper or cover an oral presentation. But before we start that, I want to cover what exactly is research, particularly from an academic point of view, and in particular from my discipline, which is chemical engineering, but hopefully it can also cover some other areas that may be of interest to other researchers. Before we start our journey, what we want to understand is what exactly is academic research. And there are various different definitions that we can find either in a dictionary or when we Google online. But the basic premise is that it is going to involve some form of investigation. So that first definition there is we are going to investigate into what is known about a given topic. It can go a little bit further than that and go into what is unknown about a topic, and we want to fill in these gaps of what is unknown. It's also a detailed study of a subject, especially in order to discover some new information and a new understanding. So there we go, what is unknown about a topic. The definition that I like, and to give a nice summary of what academic research is that it's an organized and systematic way of finding answers to questions. So obviously where we need to start at some point is going to be a question, and how we're going to do that we'll cover in the next few slides or videos. But what is the alternative to academic research? And there are going to be several different things that we might encounter. The first of these is authority. And this authority is often the legitimate power of one person or group over other people. So if I tell you something, you believe me because of my place in society, my background, my sort of authority, and that's the wrong thing to be describing a word with another word, but it's that power of one person over another that leads to that authority. The next alternative to academic research is tradition. And this is typically the transmission of customs or beliefs from one generation to another. So again, there's no questioning like in authority. Our elders or our parents say one thing and we believe what they say. We then tell that to our children tell it to their children, and that tradition goes from one family member to the next, or one generation rather to the next. Common sense, which is the sound, practical judgment concerning everyday matters, or it's a basic ability to perceive, understand, and judge. So based on our general understanding of things, we can take our learnings from one experience and take them into another, and we can learn from what we have seen around us. The fourth alternative to academic research are myths. And this, in my mind, is often similar to tradition, where it's stories that are based on tradition and have been passed down from one generation to the next. Some of these might have factual origins, or there was a misunderstanding of the science many generations back, which then lead down the generations or from one decade to the next. Some of these are completely fictional. Somebody made these up. And again, this might be something from authority or something else. And these myths just seem to go from one generation to the next. Some things that are myths, like the Loch Ness Monster or the Yeti, somebody thinks they have seen it or seen something similar, and we now want to go and we want to believe, or we don't want to believe, but we go and find out and we investigate these myths. In my mind, myths and traditions can be a little bit similar. Are often completely, not often, myths can be completely fictional. So in my mind, the difference between myths and tradition is that my grandmother will pass down a recipe, her secret traditional recipe on how to bake something, versus a myth is often, in my mind, something more fictional or fantastical that probably doesn't exist. The last one that we have here is personal experience. This is the direct experience of an individual. Another thing we need to compare is what is the difference between research versus evaluation. In research, we basically look to prove or find new knowledge. It's often a researcher-focused activity where recommendations from this lead to new knowledge. The basis of research is often scientific inquiry and is set in a controlled environment. What it does is it advances the broad knowledge and theory of what we were looking at. Evaluation is often a stakeholder-focused activity where we are looking to improve something. We are looking at generating new information, often for decision-making, and not just for the sake of finding new knowledge. The evaluation can have a policy interest of the stakeholders that have asked us to do this evaluation processes, and it can be conducted with changing actors, resources, and timelines. So, depending on who is asking us to do what, the research that you're looking at might actually be an evaluation, and the gray area that exists between the two can often become a little bit confusing, but often it doesn't necessarily matter which one we are doing. But obviously now we want to know, why would you do research? And there are three general ideas on why we would want to do research. The first one is curiosity. The next one is to test changes to an existing system. And the last one is to determine environmental or cost implications. So the obvious one here is curiosity. I want to understand why. There's either a desire to learn, to find out something new, or just because I don't know and I want to sort of understand what is happening in my environment. The second one is to test changes to an existing system. So in engineering, this is quite a common thing, and it's going to lead to the third point there. But what happens if we change something? If I change the temperature, if I increase or decrease a parameter such as pH or pressure or something else, what will exactly happen to that system? And those changes in an engineering setting or in economical environment are going to say, what is the effect then on the cost? So if I have to change something, is it going to save me money? Is it going to cost me more money? Can I make it cheaper, or will it lead to something being more expensive? Those changes can often also have an environmental cost. So we want to do research to understand, are we going to harm the environment? Are we going to make it better for everyone in the area? And how much will this change cost? The next thing to look at is that we have two different sides of research. There is academic research and there's also industrial research. Typically, academic research is going to be at a university or a college of some sort, and it doesn't necessarily have as many cost implications as industrial research might have. It may not have any impact on people, whereas industrial research is obviously going to have financial implications. We want to do this for some company, or often for some company, to make it better for them. But either way, we are going to have different goals, different timelines, and different reporting structures. For academic research, that goal is often going to be a degree or a simple understanding or a curiosity for what we are researching. The outputs for this are going to be journals, conferences, or a degree type structure. And the timelines for this can be years for a master's degree, even more years for a PhD degree, or they could be even longer than that, where we have research groups with several different PhD students or master students looking at a similar topic over many years or into decades. Industrial research often has that curiosity level as well, but there is more a financial gain aspect to it, of how can we make more money. The other one that industrial research might want to cover is a legislation type question of reducing pollution or something similar to that. Industrial research cannot take decades to solve. There might be a very pressing timeline on it. So the industrial research, typical industrial research, may only be weeks or months. Often there is a partnership between academia and industry. So again, these different goals, timelines, and reporting may be very different, or may be similar rather. Let's not say that very different. The last point to note here is that in academic research, we aim to publish everything. We want things in journals, conferences, and get as many people to hear our work as possible or see our work as possible. Whereas in industrial research, what we are looking at is to improve a company standing. So a lot of these reports may only be internal reports. We may have confidential findings. So it's not always obvious to know what it is that the industrial researcher found out, because the results are often going to be hidden. In research, we also have various different types of research, from basic and applied research to quantitative, qualitative, longitudinal, cross-sectional, and various other different types of research. The point of this slide isn't to go through each and every one of these, but maybe to pause on this to just get an understanding of all of these different types of research and which one you are looking at. Typically in my field, chemical engineering, we look at both basic and applied research. So things that are looking at basic understanding and fundamental principles of the basic research, but also applied to looking at solutions to practical problems. Typically, we would look at quantitative research to find the actual numbers of the study and to get some mathematical formula around this. And then after that, we would look to have some explanatory or theory testing and theory building type research on top of that to get some results from all those numbers that we have So once we have all of our research and we have completed it, the next step is going to be to work out what type of outputs do we want from our research. We've already mentioned some of these things in academic versus industrial research on where and how we want to output it. But going through this again, we might want to look at a degree, so either a coursework or an MSc or PhD postgraduate degree. We would want to publish in a scientific publication such as a journal or a conference where we can have an oral or a poster presentation. Books are becoming fairly popular in engineering work where we can have individual chapters or whole books. This has been very popular in the humanities for many years. But we can also have outputs such as the media, such like TV or newspapers and radio. But the other forms of outputs that are becoming even more popular these days are things like social media or blogs, where we can get our information out to a very big group of people very quickly and also very easily and cheaply, because you can actually do this yourself. But research isn't just a simple let's do research. There are going to be hurdles in our studies. And the four most common hurdles that I find are going to be funding. Obviously, we don't have enough money. It's going to be difficult to find this money. How do we sponsor or how do we fund the research? But also, how do we fund ourselves? We need to be able to live and eat and pay for our rent. So what are our personal expenses? Time. This is never on anybody's side. So it's not just an issue about research. You're going to have a time issue no matter what you do. There are also going to be ethics. So can we work on animals? Can we do clinical drug trials by just injecting random things into people? What about biobanks and human research, both medical or non-medical, as well as biosafety? The last one I want to mention here are external pressures. And these could be either your own or other people's beliefs, political affiliations, or religious views. These might not come into play in engineering. They might come into play in other areas. But the one to possibly look out for is politics, where there might be a policy or some statement that says one thing and your research is going to go against that.